Hi, morning, students. Good morning.
Good morning, sir.
All right. So it's now 11 a.m. We're going to start promptly. All right. So it is being recorded. So those who are joining late, they can always watch the video. All right. So I want to start out by going through this classwork. Mute the mic, please. Mute the mic. I want to start out by working through this classwork that we did. It's class activity. So functions and variations. So the first three questions are functions. The last one comes under the functions topic, so it's really functions, but more precisely, it's a variations question. All right, so this question gives us this function, f of x is a simple function, it's a linear function, and it wants us to find f to the minus 1. And hence, the hence means we have to use this f to the minus 1 to solve this. So basically, this question is testing our knowledge of the use of f to the minus 1, the inverse function, to solve an equation. And that's why they specifically said hence right here. All right, so I want to find the inverse function the normal way. 1 second, 1 second. 1 second. All right, I want to find the inverse function the normal way, which is to start by saying f equals 3x minus 4. I'm going to inverse it. This f, which is range on the function, becomes domain in the inverse. This x, which is domain on the function, becomes range in the inverse, which is f to the minus 1. So range on the inverse is written f to the minus 1, subtract 4. And then to make this a subject, the inverse, f to the minus 1, we're going to transpose the 4. We're going to get x plus 4, and then we're going to divide under the 3. Divide under the 3. That's a shortcut, and that is f to the minus 1. And that is really f to the minus 1 of x. So I can put in back of x now. So f to the minus 1 of x is equal to that. So I've answered the first part. And then hence, we want to solve this simple equation. So hence, we're solving 3x minus 4 equals 5. But what we must recognize is that this expression here really is the same f of x that was presented. All right. So this really is, so i.e., this really is that f of x is equal to 5. And we are using that concept that we learned, that if f of x is equal to 5, it's a one-to-one function because it has an inverse. Only a one-to-one function can have an inverse. It means that the x is f to the minus 1 of the 5. Simple as that. So what it is that the x is mapped onto 5 using the f, and the 5 is mapped back onto the x using f to the minus 1. And so that's how we can find that x value. All right. And so the f to the minus 1 was obtained by substituting 5 in this f to the minus 1 function, the inverse function. And so our x value becomes 5 plus 4 divided by 3. This is 9 divided by 3, and this is equal to 3. We're going to see some questions where we can apply this thing just the same. All right, we can apply that concept just the same. So that completes question 1. All right, question 2 is a simple question of your knowledge of the meaning of the term undefined, or what will make this function undefined. All right, and the function becomes undefined when the denominator is equal to 0. So it's a matter of finding which x value is going to make the denominator equal 0. And so what it is that this function cannot accept a value of x that will make the denominator equal 0. That value of x cannot be in the domain of the function because it will cause a function to be undefined. And so you don't want that value of x in the domain. All right, so the function is not valid on that, but when that value of x is in the domain. All right, in fact, it no longer have a function. All right, but you cannot have an element in the domain that is not mapping to an element in the codomain. All right, so this h of x for question 2 h of x is undefined or not defined when the expression in the denominator, which is a 2x minus 3, becomes equal to 0. And this equation will calculate that x value for you easily. We're trying to make x a subject, transpose the -3, becomes a +3, and then we divide by the 2. And so we're going to get x equals +3 over 2, or 1.5. And so you see that if the x right here becomes 3 over 2, then the 2 times 3 over 2 becomes 3, and you'll end up having 3 minus 3, which is going to give you 0. And as we showed, you cannot divide by 0. All right, there is no real value, but there's no real result when we divide by 0. And so the function becomes undefined if the denominator is 0 and the denominator is 0 when the x is 3 over 2. And so that is the answer. 3 over 2 cannot be in the domain on this function. All right, then we'll come to number 3. Number 3. So this was a really very easy class activity, guys. So to give us this composite function, it is equal to this. And I want us to break it and find two single functions, or two simple single functions, g of x and f of x. So this really is breaking that composite function to find two simple functions. So f of g of x is equal to 3 into 2x minus 1 plus 2. And we want to break this out into two simple functions. First thing we need to do is let the inner function, which is g of x, be equal to the expression within. All right, that's the first thing. So like we're going to pull out that inner function. We are doing the reverse of how we form the composite function. We're going to replace that g of x with x here, and also replace that f2x minus 1 with x as well. And the result is going to be our outer function, the f function. Simple as that, a two-step process. So let's write it now. We're going to say let the inner function, which is g of x, be equal to the expression within. The expression within in this case is 2x minus 1. That implies if we carry out this operation now, right, by pulling this out and replacing it with x, we're going to end up with the outer function, which is the f of x. So the f of x becomes 3 times where this 2x minus 1 was, we put in x there now, plus 2. And that is it. And if you're not sure, you can basically try to use these two functions now to reform the composite. All right, and remember this means g into f. And if you were to use these two and put the g into the f, it would come right here, and you would reform that composite function. So you know that those two single functions are simple functions are correct. All right. Next thing I want us to do in part B of this question right here is to find the inverse of each of them, the inverse of the g and the inverse of the f, and hence find this. The hence means we have to use these two things to find this. We have to use those two things to find this inverse of a composite function. So I have to know what this thing is equal to in terms of these two. And let's write it down here. Let's write it down here. What it is, you have to remember that f of g all to the minus 1, the inverse of that composite function is equal to the composite of the inverse functions. Remember that these two are switched around. So it becomes a composite of g to the minus 1, g to the minus 1 of f to the minus 1. That's what it becomes. So that is how we're going to use these two, which are these two, to find this thing that we want, which is right here. All right. So that's it. So you have to know this rule, this formula. Like you have to know this thing. You have to know that in order to use these two to find that. More than likely, the question on the real exam will say hence or otherwise. So you can find this straight by finding the f of g first and then inverse in the f of g. Results are going to be the same if it says hence or otherwise. But the hence method is always quicker. All right, hence method is always quicker, and we show that in the class on Wednesday, on Thursday. All right, so we're gonna find the inverse of these two functions now. Let's go for part B. So in part B right here, and let's start in the G first. So I'm gonna start by saying G equals 2x minus 1. We're gonna inverse it, and this range on the function becomes domain on the inverse 2 times this domain on the function becomes range on the inverse of G, which is G to the minus 1 minus 1. To make this a subject, we transpose the 1, make it positive, and then divide under the 2. Easy. So it becomes x plus 1 divided by 2. That is our G to the minus 1. And we can put back of x in there now. I'm going to put the f to the minus 1 right beside it. So now we're finding f to the minus 1. So we're doing the inverse of this one. Start out again by saying f equals 3x plus 2. And we're going to inverse it. So when we inverse this, the f, which is range, becomes domain on the inverse equals 3 times the x, which is domain on the function, becomes range on the inverse. Range on the inverse of f is written f to the minus 1 plus 2. And then again, we're trying to make this a subject. We're going to transpose the 2, subtract it, and then divide under the 3. So it becomes x minus 2 divided by 3. That leaves us with f to the minus 1. So that is our f to the minus 1 of x right here. All right, and now we want to use the hence method to find this, as we said, over here. And we are going to be using this identity. All right, so I want to say hence. Let's do it in purple. Let's do it in purple. So basically finding this now, all right? So I want to say hence fg all to the minus 1 is equal to, note that I've left off this of x expression. It's not absolutely necessary for you to put it. All right, so I've left it off. It's actually equal to g to the minus 1 of f to the minus 1. And that's how we're using these two things to find out what this is. All right, and how is this composite formed? It's formed by substituting the f to the minus 1 into the g to the minus 1. So it means that we're taking all of this f to the minus 1. I'm going to bring it and put it into the g to the minus 1 where x is right there. That's what we're doing, to put the f to the minus 1 into the g to the minus 1. All right, so that result is going to be where the x is, we put in all of the f to the minus 1, which is x minus 2 over 3. Put back the plus 1 beside it, that this plus 1 beside it, and then everything is being divided by 2. And that is it. If we were to simplify it to get rid of this fraction, we can quickly multiply the numerator by 3. But if we multiply the numerator by 3 to eliminate this fraction, you have to also multiply the denominator by 3. So it's almost like we're multiplying by a 1. So we're not changing the value of that expression. All right, and so this then will become equal to 3 times this fraction will cancel this 3 and leaves us with x minus 2. And then 3 times this positive 1 will become positive 3 divided by 3 times this 2 now under here gives us 6. And then 3 minus 2 is 1. So this becomes x plus 1 divided by 6. Now, students who left this in the classwork, I allowed it to be correct. But most in maths, you're generally expected to simplify expressions. And this is a more simplified form of this expression. All right, so we need to be able to go from this expression to this using simple adjustments like this one that I used. So it's something that we have to practice. But okay so far?
Yes, sir.
But all right so far? All right, good. All right, so let's move on to
So I have a
next.
question.
Yes, go ahead.
The x minus 3 not times by 3.
Go again. Ask the question
Why the
again.
x minus 2 not times by 3?
No, if you're multiplying, because I canceled, I used it to cancel this 3. If I'm multiplying x minus 2 over 3 by 3, then this cancels this 3. That's it. And so I'm left with x minus 2. You see that?
Yes, sir.
All right. Hold on a second. I think I turned off on my phone. All right. All right. So you're clear with that, right? And it's shown another way. Shown another way to multiply by this 3 is same as to multiply by 3 over 1. So this cancels this to give us 1 and 1. So the overall result is going to be x minus 3. All right. So if you multiply, put it this way, if you multiply a fraction, like a over b by a number n, you generally multiply this by this alone. And so the result would be an over b. But what happened is this, if this n, for example, was 2b, then the b could cancel with this b, and you're left with a times 2, and that would be just 2a. All right, so you have to get comfortable doing these simple fractions. All right, so that finishes the functions questions. We're going to jump now and look at number 4, which is our variations question. This question down here. All right, so let's go. I'm going to do some variations questions from past papers, so I don't have to like teach it from here. We're going to see various types of variations questions. All right, while doing a couple of past paper questions just now. Mute back your mic, please. Mute back your mic. All right, so we're doing this question here now, guys. All right, so this question says, it is given that y varies directly as the square of x. So this is the important statement right here. This is the variation statement. Firstly, the key word here is directly. And the variables are y, and the square of x is x squared. All right, so the variables that are related are directly related to each other from this statement are y, and the square of x means x squared, and it's a direct relationship, direct variation. When it's a direct variation, it becomes a k times y equals k times. So the first variable is y equals k times the second variable when it's a direct variation. As simple as that. If it was an inverse variation, then it would be k divided. First variable will be equal to k divided by the second variable. All right. So let's write the variation statement, right? As a mathematical expression, which is y equals k times x squared. This is what that statement means that we underlined over here. All right, and the question is telling us to use the table, telling us to use the table, use the values of x and y in the table to calculate the value for p and the value for q. And the method we're using in the class is one where we say we're gonna always find k first. It can be done without finding the k because this question is not asking us for k, for the value of k. We're practicing that we know because a lot of the questions will ask for k. And so we say we're gonna find k first. We're always gonna find k first. Let's do it that way. We'll find the k first. Find the k value first. Constant of variation constant. Find that value first, because when you know that value, you put that value here, and then you will know the relationship fully between the x and the y and the x squared. So what do we use to find the k? The question will always give us a pair of values, known x and y values, that we can use to find the k. You just need to look for it. Sometimes it's in the table, sometimes it is in the statement that they give you. This time it is in the table. This is your known pair of values that you're going to use to find k. So using those two values for k. So what do we know? We know that when x equals 2, the y equals 8. All right. So when x equals 2, the y value is 8. We're going to use these two values on this relationship formula that we don't know yet fully. We need to find a k from it. So just plug them in there. And so when you plug them in there, the y value is 8. So you're going to get 8 equals k times the x value is 2. So you're going to put 2 squared there. So it's k times 2 squared. This 2 squared is 4. And if you divide the 4, 8 over 4 is 2, or you consider it is 2 times 4 that is equal to 8. So any way you want to look at it, the k is equal to 2. K is equal to 2. Now that you know that the k is equal to 2, we're going to substitute the 2 right here. For the k is a constant, it's not going to change. Where the x and the y values are changing because they are variables, the k is a constant. So its value will stay the same on the relationship. So we now know that the formula connecting x and y is that y is equal to 2 times x squared. This is now your formula. You now know the formula fully. And so we can use that formula on this pair to find p, and on this pair to find q. Let's say we're using it on the first pair right here. Using it on this first pair, which is that x equals -1 when y equals p. We are substituting these values in the formula to find out what the p is. So we can say, therefore, the y value is p. I'm going to put p for the y value. Is equal to 2 times the x value is -1. I'm going to put -1 for the x value. And I'm squaring the entire -1. -1 squared becomes a +1. So this really becomes 2 times 1. 2 times 1 is 2. So it means that p has a value of 2. That is a value for p. I'm going to use a formula on the other pair, this pair, which is when x equals q, y equals 18. I'm going to use a formula on it. X equals q and y equals 18. Again, I'm going to plug these values in this formula, all right, to find out what q is. And so I'm saying, therefore, the y value is 18 right there. So I'm not going to write 18 is equal to 2 times the x value is q. In this case, the x is q. So I'm going to write q squared. And so now I'm solving this for q. First thing I want to do is divide both sides by 2. Or shortcut, we say you divide 2 under here. Whichever way you look at, the 18 divided by 2 is 9. And so q squared is equal to 9. And then to make q the subject, we need to get rid of that square. And so we're going to be square rooting both sides. So we're going to square root the 9 and square root the q squared. Square root both sides. And when you square root both sides, the square root of the 9 is really plus or minus 9. And is really plus or minus 9. So this is really plus or minus the square root of 9. Sorry. So this is really plus or minus 3 equals the square root of this q squared is q. So the q is either plus or minus 3, but we have to decide whether we're going to be using the plus 3 or the minus 3. So it goes back now to the information that the variation is direct. And when the variation is direct, what you know is that as x increases, the y also increases. So both values must be increasing. So if we reach 2 here and the value must increase this way because the y value has increased, then it means that this cannot be -3. It has to be a +3. And there's another scenario. If it was an inverse variation, and you know that the value is supposed to be less than 2, then in that case, you'd have to choose the -3 if it was an inverse variation. And that's why you need to consider here whether it's a positive or negative value and then choose the correct one. In this case, because it's a direct variation and the values are supposed to be increasing, because a direct variation is that when x increases, y increases. In this case, it is y and x squared. So when y increases, x squared increases. And if x squared is increasing, means that x is also increasing. So we cannot use the negative 3 in this case. So we're going to say Q equal -3 is not valid in this case. And so the solution, or the value for 3 we want, is +3, and that's the answer for Q. All right, in another question, depending on if the variation is direct or inverse, the -3 possibly could have been the correct answer. So when you get the possibility that is one answer or another, you have to look back at the variation, see how the values are changing based on the variation. Remember, if it's a direct variation, then the two variables are increasing at the same time, or the two variables are decreasing at the same time. If it's an inverse variation, then what happens with an inverse variation is that when one value increases, the other decreases. And so you have to look at the scenario and make sure you choose the correct answer when the possibility exists that it's one of two answers. All right, so that completes the classwork, guys, class activity. Everybody good at that?
Yes, sir.
Yes, sir.
All right. So we're going to look at some past papers now. And we're going to pick out some variations questions and some functions questions. I know we did some functions questions last week. But last week we were focusing on the functions questions that are set quite frequently, right? This week in class, we looked at functions questions that are not set very often, all right? The more infrequent ones. Some are more infrequent than others, all right? So let me start. I'm going to close this down and let me go and pick out the first paper that we're going to do. We're going to do the 2023 paper. There's a functions question on the June 2023, which is the very last exam, the exam that was actually scrapped by CXC because of the leak. All right, this is the very last exam that was set, and there's a functions question up at number 4, up here somewhere. Number 4, right here. There you go. All right, there you go. All right, so this question gives us 3 functions, f, g, and h. 3 different functions. Mute the mic, please. Mute the mic. First part wants us to, for what value of x is f of x undefined? Remember, it becomes undefined. This is the f of x. It becomes undefined when the denominator is equal to 0. So the value of x that will make the denominator equal to 0 is the value of x that will make that rational function. It's called a rational function because it is in the form of a ratio, form of a fraction. And the denominator, if it becomes 0, then the function ceases to exist. It cannot produce a value. So you don't want that x value on your function. All right, the function is undefined. If x is that value, you don't want x to have that value. You don't want that value in your domain. All right, so to find that value, the function is undefined when it's undefined, when the denominator x plus 2 becomes equal to 0. And it will become equal to 0 by solving this for x, transpose this 2 over here, and you see that the x will be equal to -2. So that's the answer. You don't want -2 as part of a domain because it causes the function to give an error message on a calculator, for example, if you try to work it out. All right, so you don't want x to have this value. The function becomes undefined when x is equal to -2. Simple as that. 1 mark for that, quick and easy. Then we go to the next question, which is to find g of a quarter. So g of a quarter simply means that we're going to put the quarter in the g function and solve for it. That's all, g of a quarter. So this becomes equal to 4 times a quarter minus 5. Hold on a second. Our class. All right. So 4 times a quarter is 1. I'll subtracting 5. 1 minus 5 is -4. Nice and easy, quick and fast. This was on the May, June 2023 paper this year. All right, so it's the standard of the questions right here. Then I want h of -3. I'll find h of -3. Easy. Plug the -3 in the h function right there. Let's look at it. This is just a x squared, so put a -3 there. Simple as that. All right, so that becomes, let's write what h of x is. H of x is x squared minus 1. Is it minus 1? Plus 1. All right, so h of -3, as I said, is put in the -3 here. So this simply becomes equal to -3 squared plus 1. The -3 squared becomes a positive 9. So this is 9 plus 1, which therefore is 10. Easy again. All right, next question. This one's f of 0. F of 0. So what does this mean? Let's write what f is again. F is 3 over x plus 2. Let's write it down here. So it's beside the question. F of x is 3 over x plus 2. This f of 0 could have also been written f squared of 0, means the same thing. F squared of 0 is the same as f of 0. So what this means is that I want to find f of 0 first, see what that is, and then substitute that value back into the same f. That's what it means. All right, so we can set it up like this. It becomes equal to f of, I want to calculate this f of 0 part inside here now. Because we're doing f of 0 first. All right, we're doing this first, the f of 0 first, which is to put 0 in this. So it becomes 3 over 2. Because if you put 0 here, this just becomes 3 over 2. All right, so we're doing f of 3 over 2 now. What does this mean now? I want to put the 3 over 2 back in the same f function, because we're now finding f of 3 over 2. This inside here is f of 0 now. So let me write it another way. Let me write it first. This is the same as f of 0. And the f of 0 is when I put 0 there, it becomes 3 over 2. So this becomes f of 3 over 2. And then the f of 3 over 2 now means that we'll put in 3 over 2 right here for the x. And so then it becomes 3 over 2 plus 2. That's the answer. Now, okay, we'll simplify this quickly. Again, to get rid of this fraction, we can multiply the denominator by 2. But if we multiply the denominator by 2, we also have to multiply the numerator by 2. And so in a simplified form, this would be 3 times 2 is 6 over 3 times this becomes 3, because the 2 cancels this 2. And so we'll get 3 plus 2 times this 2 is giving us 4. So the final value is 6 over 7. 6 over 7. That's the final answer. If you want, you can type this in the calculator and you'll see that you get the same answer. But okay with that? But all right with that?
Yes, sir.
All right, good. Let's move on. I think this question is over. Nope. They want us to find that composite function and they want us to simplify it. All right, let's write what the g is and what the h is so we can composite them. Let's write it up and then copy it down. So remember now that the g of x is 4x minus 5 and the h of x is x squared plus 1. So I'm just going to copy this down on the next page so everything in front of us working with. All right, let's copy it down here. We're going to use them. Let's paste them here. All right, so compositing these two functions. Now we have to remember now is that this g of h means h into g. Remember the h is the first function, the g is the second one. Remember it means h followed by g, that's what it means. And to get the composite, you substitute the h into the g. How do we do that? We take the entire h and substitute it into the g where the x is. That's a quick way to do it. Quick and fast, nice and easy. And the result of that movement is g of h of x, which is going to be 4 times. They're putting all of the h there, which is x squared plus 1. And they're subtracting back this 5 minus 5. And the question said simplify. So we're going to just expand it out, simplify it. We get 4 times the x squared is 4x squared. And then 4 times 1 is 4. And the 4 minus 5 is -1. About to go to that. That's the answer right there.
Yes,
4x
sir.
beautiful. That's it. So this was a May 2023 exam. Oh, I have yet another thing. So this question nice and long. I like it. Another one, g to the minus 1 of -2. Let's copy the g down again. We have the g here. It is 4x minus 5. So let's write it here. So the g of x, remember now, is 4x minus 5. Now, this can be done several ways, but the method we're going to focus on using now until the master function some more is to actually find the g of to the minus 1 first and then substitute the -2 in the g to the minus 1. So let's write it. What we're going to do. Let's write what we're going to do. Right? There are other ways to do it. What we're doing using this method for now. So we're going to find g to the minus 1 of x first. And after find the g to the minus 1, then we will find g to the minus 1 of the -2 by substituting the -2 in the g to the minus 1. That's how we're going to do it. All right, let's put a line and do it over here. All right. So this is the g. I want to start by saying g equals 4x minus 5. We'll just leave off the of x for the time being to keep the expression simple. Some teachers just call this y. All right, so some teachers will just put a y right here. Nothing wrong with that. I use g, same difference. We're going to inverse this now. So the g becomes x equals 4 times.
X.
Mute your mic, please. Mute your mic. Mute your mic. Do not preempt. Mute your mic. Mute your mic. Do not preempt. All right, 4 times. The x becomes g to the minus 1. So x becomes g to the minus 1. All right, this is the range on the inverse function, minus 5. And then we're trying to make this a subject. So I'm going to transpose the 5 and then divide by the 4. All right, so we're going to get x plus 5 divided by 4. That gives us g to the minus 1. And this really is g to the minus 1 of x. I'm going to put the of x part there now. And so from this now, we can find the g to the minus 1 of -2 by substituting the -2 in there. So we can now say, therefore, g to the minus 1 of -2. So we'll substitute the -2 here and there to get what that value is -2 plus 5 divided by 4. Then it becomes 5 minus 2, which is 3 over 4. That's 3/4, that's 0.75. But that is the answer right there. All right, that is that. Very good. So remember, guys, so I do them first here, and then you go and redo the questions. All right, so you don't have to do it along with me now. Just follow. If you know what to do, just follow in your mind, not a problem, but cannot be speaking while I'm speaking. All right, so you, after the class is over, you can use the video, look back at the questions, pause the video, do the question on your own, use the video to check your work and see if you have the right thing. If you don't remember something, you'll see the explanation again. All right, but this class is about me explaining the solutions. All right, you'll get your opportunity in class or on your own, or when we get closer to the exams, you'll get the full exam papers to do. All right, and that is when you express yourself. All right, let's continue. This finishes this question. All right, so that is that. Let us do a variations question. I want us to do a variations question now. So we're jumping between functions and variations. Remember, variations really comes under the functions part of the syllabus. All right, so we're looking for 2019 question 4. There's a variations question on June 2019, question 4, this one. All right, let's see. So it has a functions on it, right? Well, this is number 8, June 2019, number 8. That's a function, but I think there's also a variations up at number 4 on this paper. Let's see. This is question 4 looking for. There you go. So this is May 2019, question 4A. And that's a variations question. I see not every time they're gonna give you X and Y. This one says quantity P might be pressure in a cylinder in some container, varies inversely as the square of V. V might be volume in a container, all right, or in a system. Remember, the square of V is V squared. So my two variables are P and V squared, and the relationship is inversely. So when it's inversely, the first variable becomes K over the second variable, which is V squared. That's what that statement means. Simple as that. Inversely means K divided. What is the question saying to do? It says using the letters P, V, and K, where K is a variation constant, form an equation connecting quantities P and V. So basically they're asking us for the formula, right? Connecting the P, the V, and the K. Remember, this is a square of V, guys, which is V squared. So it means then that formula is that P is equal to K times V squared. No, not K over V squared, inversely, my mistake. K over V squared, it's inversely. So it's P equals K over V squared. But good at that?
Yes,
Are you okay
sir.
with that? Good. Inversely, if it was directly, it would be P equals K times V squared. If it was directly, but it's not directly, we have an inverse variation. All right. Then it says, given that V equals 3 when P equals 4, this information is to help you find the K. This information is for the K. You don't have to find the K, but you can do the question by finding the K. Maybe closer to the exam, I show you how to do it without finding the K. The question does not ask for the K. It says determine the possible value of V when P equals 1. Determine the possible value of V when P equals 1. So you're trying to find V when P equals 1. So I want to find the K first, guys, using this information. Let's use that method. All right, let me move this down a bit. All right, so we're going to find the K first as usual. All right, so let's see, find K first. We're doing variations questions. This is the method that we're using, finding K first. I'm using this pair of values to find K. The V equals 3 and the P equals 4. We put in these values in this formula to find the K. All right, so what you're gonna get is that the P value, which is 4. So I wanna say therefore 4 equals K divided by the V is 3, so it's V squared, 3 squared. Well, this 3 squared is 9. This 9 gonna come over and multiply by the 4. 9 4 is 36. So the K is gonna be 36. So that's a constant. So now the K is 36. This 36 can come up here on the formula, and they will know the formula fully connecting the P and the V. So we can use this now. Since the K is 36, our formula becomes, so we can go back to the blue now. And so therefore, P really then is 36 over V squared. And then now, this is the formula known, fully known. But I want us to find what the value V is when P equals 1. So it means that we need to put the P equals 1 right here. And then work out the V value. So let's write it. When P equals 1, it means that 1 right here is going to be 36 over V squared. So it simply means that the v squared equals 36 now. If I multiply the v here, we're going to get the v squared equals 36. V squared equals 36. I'll put another way. If a fraction is equal to 1, then it means that the numerator and the denominator equal. Right? Put another way. And then if v equals 36, then we square root both sides to get the v. Then the v would be plus or minus the square root of 36. So the v will be plus or minus 6. In this case, I'm going to leave it like that. But the question said, oh, it's I wanted a positive, or they wanted a positive, or not possible positive. So the answer, or the positive value, is that v equals 6. So you see why the question specifies positive? Because the answer can also be negative, right? The positive 6. So that's my answer right there. The positive. They wanted a positive. I thought it was possible. It's positive. They wanted the positive value of v. I could have also asked for the negative, right? But that is it. It could be plus or minus 6, but the question asks for the positive. So we'll give them this as the answer. Very good at that? Very okay?
Yes, sir.
All right, good. So that's a variations question. On the same paper, we just saw a functions question over at number 8. All right, so let's go down and do that functions question on this paper. This is May 2019, just the other day. All right, this is the year before COVID. Before COVID hit. Or the same year COVID hit, about the November, December, where it started in China and then affected the rest of the world in 2020. To the extent that there was no paper 2 in 2020. All right, so here's a functions question right here now. This again is a rational function, is it? A fraction. All right. So this one says, state the value of x that cannot. See, asking the same thing now. It's the same undefined basis now. State the value of x that cannot be in the domain of f. Same undefined. It is the value of x that will make the function undefined. Same thing. That value of x will make the function undefined. What value of x will make the function undefined? Same thing. This question is asking. It says again when the denominator equals 0. Right? This question is asking the same thing. It cannot be in the function. It cannot be in the domain of f because it will make the function undefined. All right. So this happens. This happens is this you don't want the value of x that will make the denominator equal 0. So that is when the 2x plus 1 equals 0. It is the value of x that will make the denominator 0. That's the value of x that you don't want in the domain. So to find the x here, we transpose the 1, it becomes a negative 1, and then divide the 2. So you get x equals negative half. And so if x equals negative half right here, it's going to become negative 1 plus 1, which is 0. And that's what you don't want. And the function becomes undefined when x is negative 1. So this is another way of asking you to find the value of x that will make f undefined. All right, it's that. So you see that can word the same question another way. All right, next part says, find in the simplest form the expression f of g. So remember, f of g now means the g into the f. Let's set it up. It means the g into the f. So I'm going to do that construction and write the result. Put in the g into the f. How put the g into the f? All of this g, let's put it in red. All of this g coming into the f where the x is right here. That is all. All of the g going to replace the x. And that's what form that. That's how I put g into f to form this composite function, f of g. All right, so that result, we'll do that construction, it's going to become equal to 9 over 2 times, where the x is now going to put x minus 3, and you have to put the plus 1 beside it. That's what we're getting. I'm going to simplify this in the simplest form. So it becomes 9 over, it becomes 2 times x is 2x. Then 2 times -3 is -6. -6 plus 1 is -5. So we get 9 over 2x minus 5. That is my answer right there in the simplest form. But okay with that? Very good at that?
Yes, sir.
Yes,
All
sir.
right. Moving right along. 2 marks are doing that. They want f to the minus 1. Let's see what f is again. F is 9 over 2x plus 1. All right. So let's write it. We want to find this. We want to start by saying f equals 9 over 2x plus 1. We want to carry out the same process. This is the range on the function. This is the domain on the function. We're going to inverse them. This range on the function becomes domain on the inverse equals 9 over. This domain on the function becomes range on the inverse. Range on the inverse is written f to the minus 1 plus 1. We're now trying to make this a subject. All right? We're now trying to make that the subject. I'm going to do it a quick way. I'm going to multiply all of this up here and take the x and divide it under there. Cross multiply, cross divide. All right, and I'm gonna get 2f to the minus 1 plus 1 equals 9 over x. But understand that? Very good at that?
Yes, sir.
Good. I'm gonna transpose the 1. And after transpose the 1, we're gonna divide through by 2. So let's go step by step. We're gonna get 2f to the minus 1 equals 9 over x minus 1. And then if you divide 2 by 2, you can go and write f to the minus 1 equals 9 over x minus 1 all over 2. Or you can divide each value by 2. So it's like we divide each value by 2. So to move this 2 from here, it's like you divide each thing by 2. So you divide this by 2, you divide this by 2 and put 2 on here and divide this by 2. So you divide everywhere by 2. I'll put another way. Instead of dividing 2 by 2, we can say you multiply everywhere by half. So you half this, half that, and half this. Multiply everywhere by half. There's various ways you can get rid of that 2. All right. So the end result, or one end result, not just one way to express it, but one good end result is that the f to the minus 1 becomes, if I divide this by 2 and multiply by half, I'm going to get 9 over 2x minus, if I multiply this by half, it becomes half. So that's one way to express it. All right. And then I'm putting back my of x right here. And that's it. But I go to that, I'm leaving this as my answer. That's not the only way to write the answer, but that's good enough. Another way to write it is to make the denominator the same. I write as one fraction. So it will become 9 minus x over 2x. Or did I get that? By multiplying this by x over x. If I multiply this by x over x, then this denominator is 2x and this denominator is also 2x. So since I have the same denominator, I could do the 9 minus 1x, which is 9 minus x up here, all over 2x. So that's another way to write it if you want to. Let's leave those red markings on it to show how we could get it like that. So you could leave this as an answer in blue, or you could leave that as the answer. That's it. Very good. So you have to be able to transpose when you're forming inverse function, especially of the rational ones, the fraction ones. But okay with that?
Yes, sir.
Yes, sir.
Yes, sir.
All right, good. Let's see if there's anything else. Nope. So we are done with that one. More maths equals better maths. Let's do another variations question. There's a variations question on June 2016. Let's go and find it. Let's go for it. June 2016. Wrong paper. June 2016. Let's find it. We have to practice. So that's how you see me coming and practicing, guys. That's how you have to practice. I don't need to be doing this, you know. You need to be doing it, but I'm doing it to facilitate you, show you the way you do it. You take the past papers and you work them and you practice. All right. So this question now, I wanted the, so this question also has a functions on it, right? But there's a variations on it as well up at number 2. So we're gonna do the variations first and then come down and do the functions. All right. The topics we're focusing on is functions. We're also doing variations. Number 2, part C. All right, there you go. There's a variations question right there. All right, let's see what this one says now. All right, so this one says the table below shows corresponding values of x and y, where y varies directly as x. So this one is simple. Y varies directly as x. So it's just y and x are the variables. It's a direct variation. So it simply means that y is equal to k times x. Simple as that. That's the relationship. They want us to calculate the value for t and u. To find the value for t and u, it can be done without finding the k, as I've said, but we're going to use the method where we'll find the k first. What are we going to use for the k? You have to use a known pair of values. You have to look for it in the table, the known pair. This is a known pair of values that you're going to use for the k. It will always give you a known pair of values for you to find a constant of variation. This is for the k. So I'm right for k. They give you this to find the k. All right. The method we're using is one where we're finding k first. Let's do it over here. Find k first. We're using that pair of values, which is x equals 6, y equals 3. And we're plugging these values in this relationship. All right. And then the y is 3. So I want to put 3 first. So it says, therefore, 3 equals k times, and the x is 6 right here. So it's k times 6. That must be a half. Half of 6 is 3. But if you divide the 6 here and get 3 over 6, you're going to get half just the same. So we say that the k is equal to half. Now that you know that the k is half, you're going to drop it in the formula right there. And so we can conclude that our formula really is y equals half x. That's our formula. And that formula will process our way of finding the u from that pair and the t from that pair. Let's go. First half of it, this pair, x equals 10, y equals u. X equals 10, y equals u. Plug these values in this formula. So we can say, therefore, the y is u. So the u equals half of the x is 10. The x is 10. And so half of 10 is 5. Done. All right. Half of 10 is 5. And you can literally look at this and know what the answer is, you know. Because these values up here are twice the values down here. So this answer must be 18 by looking at it, right? But let's just work it out still. Because just a half relationship it's kind of easy. I'm going to use this pair on it now on the formula. So we'll say that the x equals t when the y equals 9. X equals t when the y equals 9. Let's write that t like that. Plug these values again in this formula. So the y is 9. So I'm going to put 9 as a subject. And say 9 equals half of the x value is t. So I'm going to put t for the x value here. And to find the x, to find the t, so I'll just multiply by the 2. And you say that the t equals 18. Now everybody know that half of 18 is 9. So anyway you want to look at it, t is equal to 18, as I've said. So t equals 18, t equals 18. So those are my answers. U is 5, t is 18. Nice and easy one, this one. Nice and easy, simple, straightforward. This is in 2016. All right, but good? But okay?
Yes, sir.
Yes, sir.
Right, so we're going down now.
Yes, sir.
To that functions question. I think this functions question is one of the ones where we have to deal with the inverse of a composite function. And I think it's a proof rule one as well. You have to prove something in it, all right? Inverse of a composite function. All right, so this question is asking us for a series of inverse functions, f to the minus 1, g to the minus 1. They ask us for the composite. Then they want us to inverse it. So after we get this, they want us to inverse it here. Got it? You can see that. And then now they want us to show this. And this time is not of x and it's of our value. We just have to work out this side, see what the value is, work out this side, see what the value is, and the two values must be the same. All right, so let's go and do this thing. Let's go. Step by step. All right, so two simple functions. Well, this one is linear, and this one is quadratic, right? All right, so they want f to the minus 1 first. So we're doing the inverse on this function f. So we're going to start by saying f equals 2x minus 7. I'm going to inverse it. The f becomes x, and the x here becomes f to the minus 1. 2f to the minus 1 minus 7. To leave this as a subject easily, we're going to transpose the 7, get x plus 7, and then divide under the 2. So you see we're doing the same thing every time. So it becomes x plus 7 over 2. That is f to the minus 1. So we can write it here. Therefore, that is f to the minus 1 of the x. So putting in back the of x now. Now that we're finished, right? So f to the minus 1 of x is equal to x plus 7 over 2 equals x plus 7 over 2. Nice and easy. Then we want to inverse the g. That's this one. Inverse the g. All right. So let's go. I want to start by saying that g equals x squared plus 1. Then we're going to inverse it. When we inverse it, the g becomes x, and the x here becomes g to the minus 1. So I'm going to write it like this. G to the minus 1 is the x, but it is all squared. All squared. And then now, plus 1. I'm trying to make this a subject. Therefore, I'm going to transpose the 1, subtract it first. Let's go step by step. X minus 1 equals g to the minus 1 squared. Then to get rid of this square, we have to square root both sides. So we square root this side and square root this side. Let me tell you something now. When you're working a function, right? A function cannot give you two outputs. So you cannot put plus or minus on the function. Whereas you can put plus or minus on a value, you cannot put plus or minus on a function. And in this case, you have to assume it's just a plus. All right? Because remember, a function, for it to have an inverse, it has to be a 1-to-1. So you cannot go put plus or minus there, because then it will be 1-to-many. All right, so we cannot put plus or minus, guys. It's just a plus. We're going to assume it's just a plus. So the result now is going to be that the g to the minus 1 is equal to the square root of x minus 1. Let's write it up here. So we're going to put in by the of x here now again. Let's write it in red. Put in by the of x. And so we're ending up that g to the minus 1 of x really is the square root of x minus 1 using a positive square root. All right, there are situations where it will be the negative square root, but we're assuming that it is a positive. All right, let's go. It cannot be plus or minus. A function cannot have two outputs. It can only have one output. All right, so here now they want us to form f of g. Now remember, f of g means g into f. Let's mark it on this. So remember, it means g into f. Let's write down what they are again. So the f was 2x minus 7. So let's write it. F of x, it's in blue. The f of x, remember, is 2x minus 7. And the g of x is x squared plus 1. That's what they gave us up here. All right, and that. And then they want us to form the f of g, which means g into f. So we can write and say, therefore, f of g of x, let's put it again, which means g into f. How is it done? Taking all of this g, I'm going to bring it and put it into the f where the x is right there. That's how we put the f, the g into the f. All right, that's how we put the g into the f. And so we get 2 times all of the g is x squared plus 1. You have to subtract back the 7. Let's simplify it now. 2 times the x squared is 2x squared. Then 2 times 1 is 2. 2 minus 7 is negative 5. Negative 5. All right, so that is basically it. All right, that is it right there. So this is our f of g of x. F of g of x is that. Are you good with that? Are you okay?
Yes.
Yes, sir.
All right.
Yes, sir.
And here now, they want us to inverse it. So they really want us to inverse this that we just found, you know. That's what they want us to inverse, you know. All right, so we're going to inverse it. So we're going to calculate this inverse. So again, we're going to do it the same way as we would if it was a f alone or a g alone. Same process. So we're going to write by the f, we're going to leave off this of x and write it back and just write it firstly as fg equals 2x squared minus 5. Then I'm going to inverse it. But remember, I know inversing the entire fg, you know. So the fg, which as a composite is still a function, just that it is a composite function, it becomes x equals 2 times, don't be afraid now. This x becomes fg all to the minus 1. So it becomes fg all to the minus 1, but then it is squared. So I'm going to put a bigger bracket around this and square it. Minus 5. Maybe this is one of the times you might want to call it y. But that's what it becomes. But I can see that. So this x becomes fg all to the minus 1. Are you good with that?
Yes, sir.
All right. And then we're transposing everything away to leave this as a subject. So first thing we're going to do, we're going to carry over the 5, add it, and then divide under the 2, step by step. Let's go. So it's going to become x plus 5 over 2 equals fg to the minus 1 all squared. Then to get rid of this square now, we have to square with both sides. Let's make this a little smaller so we can fit everything here. Or maybe just move it up a bit. All right. So to leave this as a subject, now we need to square with both sides to get rid of this square. So I'm going to square it all of this side and get the square root of x plus 5 over 2 equals fg all to the minus 1. And that's what this is. I just leave off the of x. This is of x. I don't need to put it. They didn't even put the bracket around. That's what it should be. But this is the answer for that. Fg all to the minus 1. But I go to that. But okay. Before we move on.
Yes, sir.
Yes,
All right. Then this question says to show that this equals that. So to show it, we need to work out the left side. Let's call this side the left side, the left-hand side. Let's call this side the right-hand side and show that they give the same value. So we need to work out what this gives us, work out what that gives us. We're supposed to know that this is true, you know, because it is really the inverse of a composite function setup or identity that they are presented, right? So this is what we normally write. So if we have fg all to the minus 1, it is equal to g to the minus 1 of f to the minus 1. It's just that no put a value on it. That is all. It happens on the function, and we should know this. All right, this is what we know. But in this question, now they ask us to prove it on the values, on the 5, on a value of 5. So let's do it side by side. Let's do the left-hand side first. I'm going to do it in red. Let's do the left-hand side first. So the left-hand side is fg all to the minus 1 of 5. So it means this is fg all to the minus 1, you know? So it means that we're putting the 5 inside here. That is fg all to the minus 1. And so it's going to become equal to the square root of 5 plus 5 over 2. 5 and 5 is 10. 10 over 2. This is 10. 10 over 2 is 5. So this really becomes the square root of 5. I'm going to leave that first. Then I'm going to work out the right-hand side now, right beside it. So the right-hand side, careful now, is g to the minus 1 of f to the minus 1 of 5. Now this means that we have to work out this part of it first, f to the minus 1 of 5. How do we get f to the minus 1 of 5? We have to plug the 5 in the f to the minus 1 function. Where is it? Let me copy them and write them down here again. This was f to, this was it. This was a g to the minus 1, and this is f to the minus. Let me copy them down. Let's copy these down because we're going to be using them. Let's just copy these two down and show them down here. We're using them and show how we use them. Let's copy them down here. Let's put them down here so they're in line of sight. All right, let's put them right here. All right. All right, let's look at it now. So we're doing the f to the minus 1 of 5 first. This means that we have to do this first. Because remember, it means this function followed by this function. All right, so we're doing the f to the minus 1 of 5 first. So this then becomes g to the minus 1 of f to the minus 1 of 5, means that we're putting 5 inside here. All right, let's see what we get. So it becomes 5 plus 7 over 2. 5 plus 7 is 6, is 12. 12 over 2 is 6. So this really becomes g to the minus 1 of 6. Then how do we get g to the minus 1 of 6 now? We get g to the minus 1 of 6 now by putting the 6 in the g to the minus 1 function here. And so it's going to become the square root. I remember putting it in this function now, putting the 6 in that function. Square root, I'm putting a 6 for the x. So get the square root of 6 minus 1. And the square root of 6 minus 1 is the square root of 5. So you see, both of them give us the same value. And therefore, we have shown it. Let's move this all the way again. So we can say, therefore shown. Therefore shown. And that's our answer. We have shown that two of them, the two sides, equal root 5. And so it is true that this equals that. So questions like these, guys, I mean, this is one of the times I remember the setting one exactly set up like this. So these are questions that you redo. Just in case I set one like it again, you're not going to see it set up like this on a lot of papers. All right, so these are what I call special questions, questions that they don't set it this way all the time. So questions that they don't set in a particular way frequently, you put those questions down as special questions and you practice them and you make sure you understand them so that if they should set it like that again on your exam paper, you will be able to do it and it's not looking strange to you. That's what you want. But okay with that?
Yes, sir.
All right, so that was the 2016, and we did variations and we did functions. All right, let's continue. All right, I have a good 45 minutes left. So let's continue. More maths equals better maths. There's another question on 2014, but I want to do the more recent exams first. I'm going to jump to some January exams now. So let's look at January 2022. There is a functions question on January 2022. Let's find it. January 2022. 2022 January right here. Question 4 is a functions question there. Let's see. Right there. Similar stuff. Looks like we have done this one before. I'm not even sure, but we can do it again, no problem. If it's one that we did before, it looks like one that we did before, but no worries, let's do it again. more maths equals better maths anyway. So they give us these three functions. Giving us these three functions, f, g, and h. H is a 5 to the x there. And the first part wants us to find f of half. So f of half means I'll put in half in the f function. So this simply becomes 2 times half minus 1. Really feels like a question I've done before. 2 times half is 1. This becomes 1 minus 1, which is 0. Done. Next part wants h of 0. H of 0 means I'll put in 0 in the h function right there. And so it becomes equal to 5 to the 0. Any number raised to the power 0 is equal to 1. But if you don't know, you could put it in the calculator. You're going to get 1 just the same. But any number raised to the power 0 is 1. That is the answer for that one. What else I want us to find? I want us to find g squared of negative 3. Remember, g squared does not mean that you're going to square the function. It actually means g of negative 3. That's what it means. So I'm going to work out the g of negative 3 first, and then apply the g onto that result again. All right, so let's go. It becomes equal to g of, now the g of negative 3 means that we're going to put negative 3 in the g function right here, where the x is. And so it's going to become 3 times negative 3 plus 2 inside that bracket. Inside here is the g of negative 3. That's negative 9 plus 2 is negative 7. And so it ends up that we are finding g of negative 7. Then g of negative 7 now means I'll plug in negative 7 in the same g function again, right there. So it becomes 3 times negative 7 plus 2. That's negative 21 plus 2. That's negative 19. So the answer there is negative 19. This question feels very, very, very familiar. I could do it before. But good so far? But okay so far?
Yes, sir.
Yes, sir.
Nice.
2x minus 1 and g of x is 3x plus 2. I'm copying these down because we're going to use them on the next question. All right, down here, right here. Let's paste them there, smaller. All right. So this question now wants us to form the composite function g of f. G of f means f into g. So it means that we're taking all of this f. I want to take it and put it in the g right here where the x is. That's how we form that composite function. G of f, f into g. So let's write it now. G of f of x, which is f into g. When we set it up, it becomes 3 times. Where the x is, we are putting 2x minus 1. And if I add back this 2. Let's write what it simplifies into right here. The 3 times the 2x is 6x. The 3 times the negative 1 is negative 3. Negative 3 plus 1 gives us a negative 1. Plus 2, sorry. Negative 3 plus 2 gives us a negative 1. This is the answer for a composite function. Very good?
Yes, sir.
Yes, sir.
All right, beautiful, beautiful. Then we want us to find the inverse, g to the minus 1. What is g again? G is 3x minus 3x plus 2. Let's write it. So we're trying to find this. We're going to start by saying g equals 3x plus 2. That's what it is. 3x plus 2 is a g. And we're inversing the 3x plus 2. The g becomes x. The x becomes g to the minus 1. 3 times g to the minus 1 plus 2. Trying to make this a subject. Transpose the 2, subtract it, and then divide under the 3. So we're going to get x minus 2 over 3. That is g to the minus 1. Putting back of x now on it. And that is the answer right there. X minus 2 over 3. 2 marks for doing that simple thing. Then it says now, hence or otherwise, determine this. Hence or otherwise, determine this. All right. Now, hence or otherwise means that they're giving you two options to do it. The hence means that they wanted to use this to do this. But the otherwise means that we can do it another way. All right, let's do it two ways. Let's do it a hence way first and an otherwise way next, just for practice. Or just to show you. Our hence method means that we're using this result. And g to minus 1 is equal to this, and then they want us to solve when g to minus 1 is equal to 4. So it's like this, remember, is this, you know, so like we're solving this equals 4. All right, that's the hence method. So that would be that x minus 2 over 3 is equal to 4. And we're trying to solve it for x, determine the value of x. So we're trying to solve it for x. So we multiply up the 3 first, and we will get x minus 2 equals 12. Then transpose that and add it, and we'll get x equals 14. That's the hence method. The otherwise method now. There's another way. Is to recognize, watch this now, guys. Is to recognize that if g to the minus 1 of x equals 4, then just as we use the inverse function to solve the equation, it means that this x is equal to g of the 4. Right? This is on the inverse. We want to put the inverse of the inverse over here, which is the g. So it means that the x is equal to g of 4. That's what it means, you know. We're going to get g of 4 by putting 4 in the g function. What is the g function again? This. So that's g of x, you know. I'm going to get the same answer. So it's going to become 3 times 4 plus 2. 3, 4 is 12, and 2 is 14. So x will be equal to the same 14. Look at it. More maths equals better maths, guys. But good with that?
Yes.
All right, good. Just remember this thing. Remember this thing. Very, very useful. I'll write it one more time for you. If f of x equals a number, then x equals f to the minus 1 of that number. Similarly, if f to the minus 1 of x equals a number, then x equals f of the number. Because remember, this one is saying x is mapped onto n using f. And so f to the minus 1 will reverse mapping to move, it will map the n back onto the x. That's what the inverse does. Over here, this one is saying x is mapped onto n using f to the minus 1. And so f will map the n back onto x. Simple as that. See this in your brain, guys. It's very, very useful in some questions. Very, very useful. And it happens on one-to-one functions, because remember, only a one-to-one function can have an inverse, and that's why this will always work. It will always work. You're reversing the mapping. So if a function does a mapping, the inverse reverses it. If an inverse does a mapping, the function reverses it. All right. Okay, that is that. I think there's another question on this paper. Nope. That is it for this paper. That was a functions. Let's do a variations question now. There's a variations on 2019, January 2019. Let's go and do that one. 2019, January 2019. Where are you? Right here. All right, January 2019, number 2C as a variations question there. Practicing all kinds. More maths equals better maths every time. Study hard, pass easily. All mathematical principles can only be fully understood by solving many questions. The more questions you do, the more you understand this thing. For every topic, it's the same thing. All right. So this question is a variations question. It says the force F applied to an object is directly proportional. So the variable is F. It's directly proportional to the extension All right. So remember, when it's direct, it's K times. Simple as that. It's a very simple one. The force F applied to an object is directly proportional to its extension. In other words, the more force you apply to an elastic band, for example, is the more it stretches. Simple, which makes sense. It says represent this information as an equation in terms of F and E and an appropriate constant K. This simply means that F is equal to a constant times E. Done. Direct. It's a direct variation. So the greater the force is the greater the extension. The less the force is the less the extension. Simple. Then it says the incomplete table below shows corresponding values of F and E. It says use the equation to obtain, use the equation obtained in C1, that's this equation, or otherwise to determine the value of X and Y. That's these two values. And in this question, they give us a pair here and another pair there. We can use any one of them for the key that we want. Any one of the pairs we can use for the key. Let's use this one with smaller values. Let's use this one, this one. I'm going to use this one for the key. So you're fortunate in this one, I give you two pairs, two sets of values that you can use for the key. So I want to use this for key. And again, we're going to use the method of finding K first. It can be done without finding K first, as I've said. But this one is not asking for a key. We're going to practice the method of you finding the key first. All right, let's go. So we're going to say find K first. Let's do it here. Got a lot of space. Find K first. Now we're using this pair of values. The F is equal to 8 when the E is equal to 0.2. We're plugging these values in that relationship to find the key. All right, so the F, so we can say therefore the F is 8. So putting 8 on the subject equals K times the E is 0.2. The E is 0.2. So what is the K? You can divide by the 0.2. All right, so the K becomes 8 over 0.2, which becomes 80 over 2. If I multiply numerator and denominator, I'm just trying to work it out without a calculator. So I multiply this by 10, I multiply this by 10, and then 80 divided by 2 is 40. So the K equals 40. That is the K, 40. So now that we know that the K is 40, you can work this out with the calculator, guys. If you want, you're going to get the 40 just the same. Now that we know that the K is 40, I'm going to take this 40 and substitute it right here and get the relationship. So when I do that, I can say, therefore, our formula really now is that the force is equal to 40 times the extension. This now will govern our way forward. That's the relationship between the force and the extension. We're going to use it on this pair to find the X first, which is when F equals 25, the extension is X. Put these values in that formula. So when I say therefore, the 25 is equal to 40 times X. And so to find the X, the E is X now. To find the X, we're going to divide by this 40. So the X is going to be 25 over 40. I will just work that out with a calculator. Let's see what I get here quickly. I'm not going to burst my brain on it. Anybody there still, students?
Yes, sir.
Okay. I don't know why I keep coming off the phone. I don't know why it's dropping off the phone. And that is the X becomes 0.625. And then on the other pair over here, which is here, the F is Y and the E is 3.2. I'm going to drop these values in this formula. So the F is Y. So I'm going to say therefore Y equals 40 times the E is 3.2. 3.2. And then you work that out again. 40 times 3.2. And get 128. 128. And that's it. But good. Don't know why this thing
Yes,
is
sir.
dropping off.
Yes, sir.
Good. Don't know why it's dropping off. It keeps dropping off. Okay, hold on. Let me check something, guys. Let me check something quick. Okay. Keep dropping off, and I don't know why. Anyway, that's it. All right. So the next question is what again? 2019, number 4. Number 4 on the same paper. There's a functions question at number 4. Let's see. The functions question at number 4 on this paper. Right there. And this one brings back this whole business of function being undefined again. It's a rational function. So again, simple. It is undefined when the denominator equals 0. All right. I remember, as I said in the class, the function is 0. If they ask you, when is the function equal to 0? It is when the numerator equals 0. Let's put it here. So you want to develop x when it is undefined. So this is when the denominator, which is 5 minus x, equals 0. Has to be when x equals 5, because 5 minus 5 is 0. That's the answer for that. But if I should ever ask you, when is it 0? Let's put it in a box. We could say h of x equals 0 when the numerator equals 0, which is when x equals minus 3 over 2. So remember, 0 does not mean undefined, guys. A common mistake. A lot of people say the word undefined and think it means 0. 0 is a quantity that we can define. 0 means nothing. 0 means none. So for example, if there's no apple on the table, then the number of apples on the table is 0. So you know what 0 means. So therefore, 0 is a quantity that we can define. We know what it means. All right. So undefined does not mean 0. All right. So let's continue with this one. It wants us to find h to the minus 1. And see, that's a rational function, guys. And so you know we're going to need a number of steps to get the inverse. So let's look at it. Let's do it right here in blue. So I'm going to start by saying how much space you have. All right. I'm going to start by saying h equal, what is it? It is 2x plus 3 over 5 minus x. 2x plus 3 over 5 minus x. I'm going to do the same process. This h is range on the function. When we inverse it, becomes domain on the inverse. The x here and the x here, each of them represent domain on this function. They're going to become a range on the inverse, which is going to be written h to the minus 1. So this becomes 2h to the minus 1 plus 3 over 5 minus h to the minus 1. Let's shift this down a little bit. So x becomes equal to that. And then the whole business now is to transpose to make h to the minus 1 a subject. So if we expand it out into separate terms, then group everything with h to the minus 1 on what side of the equation, then factorize it out to get the one term, the one instance of it in the equation. All right. So I'm going to take this denominator first and multiply it across here by the x. So it's going to become the x times this and the x times that. We multiply it across. So the x times the 5 is 5x. And the x times the minus h to the minus 1 becomes minus x h to the minus 1. That is all equal back to this numerator, which is left. 2h to the minus 1 plus 3. All right. I now I'm going to transpose this over here. But because everything's going to become negative, I'm going to transpose this over here this time. And take this 3 and bring it over this side. All right. Show you that there's not one way to do the mathematics. So this is going to go over there. And the 3 is coming over here. So let's move the 3 first. We're going to get 5x minus 3 equals, this remains on this side, which is 2h to the minus 1. This minus xh to the minus 1 comes over here becomes a positive. So it becomes plus x h to the minus 1. Then we basically consolidating on that side, trying to get the h to the minus 1 on that side. So I'm going to factorize the h to the minus 1 out of these two terms. So we're going to get h to the minus 1 into out of this, I'm getting a 2. Out of this, I'm getting a plus x. And then this remains 5x minus 3. Then now I can divide this 2 plus x on here. Or it is the same as saying divide both sides by 2 plus x. Same difference. Shortcut is to say, as it's over here multiplying, we're going to divide it on this side. And so we're going to get h to the minus 1 equals the 5 minus 3x over the 2 plus x. Let's write it up here. So it becomes h to the minus 1. What happened there? My mistake, press the wrong thing. Right, so it becomes h to the minus 1 equals 5x minus 3 over 2 plus x. And this is h to the minus 1 of x. This is what I wanted. So this is our answer right there. 3 marks for that. Well, it's 3 marks for everybody, so it don't matter. But okay with that?
Yes, sir.
Is there anything else on this functions? Nope. That finishes that functions question on 2019. What time is it? All right, we still have a couple more minutes to work, some 20 minutes, so we can do some more questions. I'm gonna do 2020, January 2020. I think there's there's a variations question on January 2021. Let's go for that one. January 2021. January 2021 is a functions question on that paper right here. Question 2C. Let's see what this one says. All right, see, that's it. Question 2. You see, no D. Question 2D. This one right here on the screen. It says the distance needed to stop a car D. The distance is D. Varies directly. Cut it now. So that's D, that's the distance. Varies directly. So that means K times the square of the speed. The square of the speed S. Square of the speed S means S squared. It's a direct. The direct means K times. And then this is the D. So the D equals K times S squared. Simple as that. That's relationship. It said the car travels at a car traveling at a speed. Now, so now let's take this out. Let's take this out and read the rest of the information. So establish that that's what the relationship is. It's a direct variation. The variables are D and the square of the speed S. And it's a direct variation. So that statement means that the D is equal to K times the speed squared. That's a relationship. Then they're giving us some information to find the K now, but this time they're giving it to us in words. A lot of the times they put it in a table. This time they're giving it to us in words. It says, a car traveling at a speed of 70. So when the speed equals 70, it requires a distance of 40 meters to stop. The D is equal to 40. This is information for the K now. This is for K. That's information they gave us for K. Then it says, what is the distance required to stop a car traveling at 80? So in other words, what is the D when S equals 80? That's what they're asking us. But I want to use this for the K first. Plug these values in here to find the K. All right, so let's set it up now. Let's set it up. All right, let's do the normal way. So this is a relationship. We're going to set it up. We're going to find K first. We're using this pair of value that I put in words. S equals 70, D equals 40. Plug those values inside here. So we can say therefore 40, which is a D, is equal to K times 70 squared. All right. I'm going to divide by the 70 squared. So the K is going to be 40 over 70 squared. And let's see what kind of value we're getting on the calculator. If we're getting a weird value, I'm going to just leave it like that. 40 divided by 70 squared. So I get a long decimal. So I'm gonna leave it like that. I'm gonna leave the K like this because I'm getting a long decimal. I use that exact value. Maybe a calculator can simplify this for you and give you a simpler fraction. Let me see. Let me bring up my calculator and see. I'm not sure what I'm talking about. All right, that's why you need to get one of those textbook display calculators. All right, let's see what my calculator simplifies it to. All right, so I'm going to write it as 40 over 70 squared. And let's see what it is as a fraction. So the fraction, it is this. It's right there, so 2 over 245. So you can put that if you want, or you can just work back with the same fraction as you have it, not a problem. All right, so I'm going to work back with that fraction. I can just put as 2 over 4, 2 over 2 for that. Let me write it. Let me write it here. So the K equals 2 over 245. So it means I'm going to take this now and put it here for the K. So I'm going to get my D equals, I can say therefore, my D, stopping distance, is equal to 2 over 245 times my speed squared. So this question is asking us, what is the distance when the speed is 80? That's what it's saying. So I can say when the speed equals 80, the distance equals, I'm plugging the 80 right here for the speed to work it out. The distance to stop is 2 over 245 times 80 squared. Put in the 80 right here. And then you can work that out with the calculator again. So let's go back and work it out right here. So I'm going to, let's work it out and say fraction 2 over 245 times 80 squared. I'm getting 52 point, so the D equals 52.2 kilometers. The question asks for the distance, so you have to say, you can't just give me a D value. You have to say the distance in kilometers, because the distance in the question is in kilometers, right? No, in meters, actually, meters, not kilometers, meters. My mistake. So the distance is actually in meters. All right, yeah, it could be kilometers, sorry. Kilometers is a long distance, it has to be meters, right? So it's 52.2 meters. That's the answer. And why you might ask me, why I only use those 3 digits? Because when you're giving answers that are not exact, right, your instruction, if they don't ask you for a level of accuracy, you give your answer to 3 significant figures. And that is 3 significant figures right there. But that is it. But okay with that? But okay with that?
Yes, sir.
All right. So another question that I would advise you to do over again, because everything was in words. And pay attention to the unit of measure that was in meters. I almost put kilometers here, which would make any sense, right? Because it has to relate to something realistic. So it couldn't be 52.2 kilometers, all right, meters. All right, so there's another question that we can do, and we'll finish off with this one. It's on January 2020. All right, there's another one on 2014. But let's do the more recent one first, which is January 2020. All right, I might just finish off with that one today. You are required to watch over the video and we do all the questions, right? Bring up the video, bring up the question, pause the video, do the question on your own. All right, you need to practice. You need absolutely to be practicing. All right, if you want to fully understand what we're doing, you have to practice. As simple as that. Keep jumping off. I don't know why, but anyway, we are connected here. Let's see what I'm using on this. Don't know why I keep jumping off, but anyway, thankfully we haven't been cut off, so I keep jumping off my phone. I don't know why. So it's number 4 on this paper, January 2020. Number 4. Too far. All right. This is a nice good function to finish off today's session. Guys, they give us just one function. They want f of 4 plus f of minus 4. All right. So from time to time, I see this question like this, all right? So it's going to be f of 4 first means 4 here. So it's going to be 2 times 4 plus a 7 over 5. And you're adding f of minus 4, which means minus 4 here now. And so that's going to be 2 times negative 4 plus 7 over 5. So what will happen is you have to work out everything in this and this will eliminate each other because you're adding 2 fractions with the same denominator. And the result is going to be 7 plus 7 all over 5. Right? Because if you put everything together, you're going to get 8 plus 7, that's here. Then it's going to be minus 8 plus 7, minus 8 plus 7 all over 5, because the common denominator is 5. And then this 8 wipes out that 8, negative 8. 7 and 7 is 14. So the final result is 14 over 5. All right, nice and easy. 2 marks for that. Moving right along here, calculate the value of x for which f of x equals 9. So if f of x equals 9, means that we are putting this expression equals 9. We're putting this equals 9, because that is the f of x. So we're putting 2x plus 7 over 5 equals 9. 2x plus 7. So this means that we are solving 2x plus 7 over 5. That's the f of x equals 9. We're solving for the x. So multiply with 5 first, we get 2x plus 7 equals 9. 5 is 45. And you're going to subtract 7. You're going to get 2x equals 38. You subtract 7, 38, and then divide by 2, you get 19. Is this correct? But good at that.
Yes, sir.
Okay. So x is equal to 19 right there. The next part now says, hence or otherwise, determine this. All right, let's set it up now. It says hence or otherwise, you know. So hence means that we are using this result, right? Let's look at the hence method and the otherwise method. All right, the otherwise method is going to be a long way because we have to record f to the minus 1. So let's look at the hence method first. Hence means that we are using what we know, which is that f of x equals 9, means that the x is equal to 19, right? The x is equal to 19, you know. So it means that f of 19 is equal to 9. So the hence method, what we're using is the result from here. If f of x equals 9, the x is 19. So I mean, this means that f of 19 is equal to 9. So that result is saying f of 19 is equal to 9. Now they're asking for x to the minus 1 of 9. So if f of 19 is equal to 9, it means that 19 is equal to f to the minus 1 of 9, which is what they're asking us for here. So it means that the answer is actually 19. So we can say therefore f to the minus 1 of 9 is 19. All right, that's that method. The otherwise method here, the otherwise method is a long way now. Otherwise is always longer than hence. Is to find the f to the minus 1 first of x and then plug in the 9. That's what the otherwise method is, you know. To find f to the minus 1 first, otherwise method, we'd have to find f to the minus 1 of x first. Find f to the minus 1 of x first. Then we find f to the minus 1 of the 9. So this method is really the quicker way. And see, it's only 1 mark for it, and so they don't really expect you to be doing a lot of work. But people who don't know this relationship, that this can go from that to that, will have a problem realizing that the answer is actually 19. All right. So I don't even want to do it because it's 1 mark. I don't even want to do it, but let's do it instead. So we're going to be inversing the f. What is f again? The f is 2x plus 7 over 5. I'm going to be inversing it. 2x plus 7 over 5. So let's do it here. Don't have any space. So start by saying f equals 2x plus 7 over 5. And I would inverse it. The f will become x equals, this x will become f to the minus 1, 2f to the minus 1 plus 7 all over 5. We're making this a subject. So I multiply the 5 first and get 5x equals 2f to the minus 1 plus 7. Then to make this a subject, we transpose the 7 and divide under the 2. So it will become 5x minus 7 over 2 equals f to the minus 1. And this is f to the minus 1 of x. This is really f to the minus 1 of x. And so if you want f to the minus 1 of 9, it means that you plug 9 now into this. So we can therefore say f to the minus 1 of 9 now, mean that we'll plug the 9 here. It would be 5 times 9 minus 7 over 2. If you work that out, you're going to get the same 19 because 5 times 9 is 45. 45 minus 7 is 38. You're getting 38 over 2, which is 19. So you get same 19 as the answer. All right, that is it. So the answer is the same 19 that we got from here, but it's understanding the relationship between the function and its inverse and understanding that thing that I told you, that this thing that I told you earlier. Put it in purple one more time. More maths equals better maths. If f of x equals a number, then x equals f to the minus 1 of that number. This thing, they're testing it a lot in questions these days. All right, and I think that ends it. Yep. What time is it now? 5 minutes to. I'm going to one more question. 2014. More maths equals better maths. Let's look at it. Let's finish off one more. 2014. There's a question there on 2014 right here. All right, and it is number 9 right here. Let's finish off with this, right? Quick and fast. One more for the road. One for the road. Let's do it here. Let's do it here. I'll do it over here because it's not the recent exam where you have the space to write it. So let's do it here. One for the road. All right, let's look at it. This question right here, guys, right here. That is it, all right? That's what we're doing. It says, give us those two functions, g of x and f of x. And this is the f of x rational. It says, state the value of x for which f of x is undefined. Same thing again, part one. F of x is undefined when the expression in the denominator becomes 0. And that happens when the x equals -1. That's it. That's the answer right there. Quick and fast. Then they want g of f of 5, part 2. Wants g of f of 5. Remember, we have to do the f of 5 first. So this is same as g of f of 5. How do we get f of 5? By plugging 5 in the f function right here and there. All right, so it's going to become g of 2 times 5 plus 7 divided by 5 plus 1. And so this becomes g of, well, this is 10 and 7 is 17 over 5 and 1 is 6. And so when we're doing g of 17 over 6. And then g of 17 over 6 now means that we plug in the 17 over 6 in the g function right here. All right, so we're gonna get g of 17 over 6 is 4 times 17 over 6 plus 3. That becomes, let's simplify this. You can put in the calculator, about 2 into this goes 2 times, 2 into that goes 3 times. And 2 times 17 is 34. So it becomes 34 over 3. So it becomes 34 over 3. This becomes 34 over 3. 34 over 3 plus 9 plus 3. This 3 is the same. If you multiply it by 3 over 3, it becomes 9 over 3. So the 3 there is the same as 9 over 3. Why did I do that? Because I want these two numbers to be fractional of the same denominator. So just add the numerator. 34 and 9 is 43. 43 over 3. That is that. And then they want us one more time finishing off the inverse of this rational function. So one more time at it, guys. One more time at the rational function. More maths equals better maths. So I want to start by saying f equals 2x plus 7 over x plus 1. We're going to inverse it. The f becomes x, and the x here and here each becomes f to the minus 1. So it's 2 f to the minus 1 plus 7 over this x also becomes f to the minus 1 plus 1. Okay, we have to expand it out into separate terms. Group f to the minus 1 on one side. So the first step is to multiply this over here by this denominator, multiply denominator across there to expand it out into separate terms. So it becomes x times the f to the minus 1 and x times the 1. So it becomes x times f to the minus 1 plus x. This times this first, and then this times that. And all of that is equal to this numerator, which is 2f to the minus 1 plus 7. Then I need to get this over here, subtract it, and get this over there and subtract. So we get x f to the minus 1 minus 2f to the minus 1 equals this positive 7 is there. This x goes over and becomes a negative x. And I'm going to factorize the f to the minus 1 of these two terms with f to the minus 1 into x minus 2 equals 7 minus x. We need to divide this under here. And so we get f to the minus 1 equals 7 minus x over x minus 2. And this is f to the minus 1 of x. That is our answer right there. And we are done. Very good.
Yes, sir.
All right. So you know what the instruction is, guys. You need to go and redo all the questions. So please do them over again. Watch over the video. I'm going to post the video in the group. You guys watch the questions, watch them over again, practice the questions, try the questions on your own, and use the video to help. We're going on to a new topic from tomorrow and Monday. Brand new topic, which is coordinate geometry. All right, I'm in a nice place. I'm going to end the session now. All right, guys. So see you all in class. All right, bye-bye.
Bye.
All right, bye-bye.